In my mind, actually the most critical question I have right now is the first lightning round presenter ready to present? Do we know who the first lightning round presenter is? 50K Coalition.
First, we ready to go?
That's what I'm trying to find out.
Yep.
Who's presenting on the 50K Coalition? You are ready? Okay.
You're up first.
We're gonna. Would somebody from the committee or somebody just go out and tell the people out there that we're starting now, and these are really fast presentations, and so we don't want them to miss it.
Now, just a reminder that this morning's session was on what you do. This afternoon session is on how you do it. So it's the emphasis on barriers, opportunities, how you overcame them, how you put things together, not just what you do, but how you do it. So
okay,
great, you're on, and
Bill,
you're up on deck.
Good afternoon. My name is Constance Thompson. I have the pleasure of serving as a project manager for a movement that we have within the engineering community that is being led by the preeminent diversity-led affinity societies, ACES, SHIP, SWE, and NSBE. And we are focused on one singular goal within the engineering community, to graduate 50,000 female, Black, Hispanic, and Native American engineers by the year 2025. What makes this approach unique is that we have 43 member organizations that represent engineering professional societies. They also represent our leading nations in schools of engineering, focused on graduating 50,000 female, Black, Hispanic, Native American engineers by the year 2025. Our approach is an approach that's designed for change. It's a social impact approach, meaning that it's an approach that's designed to get people to work together to achieve a common goal, to make course corrections, but also to decide upon what their common agenda items are, what their common metrics are, and to measure that. So we actually have within our process the social impact process demands that we agreed upon common metrics, we are bringing upon common goals that we have, and we are agreeing to work towards this goal to the year 2025. As you see here, our common agenda items are in undergraduate education, undergraduate support and retention, public awareness and marketing, K-12 support, community college linkages, culture and climate funding, and financial support. Now, what's unique about this is that each organization contributed a project plan that serves as their commitment to reaching this 2025 goal. Within that project plan, they have metrics that we agreed upon. The agenda items we're going to measure with the support that we have, and we've created a backbone organization that's led by the 50K Coalition Leadership Circle and has been supported by the United Engineering Foundation and the National Science Foundation to the tune of $500,000. Thank you.
Bill? And I think the clicker is up there.
The clicker. Okay, I'm Bill Mahoney. I'm the Managing Director of ASM International. We're the world's leading association for materials scientists, engineers, and technicians. I'm here to tell you about Material Advantage. Material Advantage is a student program that was specifically created for undergraduate and graduate students enrolled in material science, engineering, and other technical engineering programs at universities around the world. We collaborate and cooperate with the American Ceramic Society, the Association for Iron and Steel Technology, and the Metals and Materials Society in running this program. The $30 U.S. membership fee provides a single low-cost membership, giving full membership access to an individual student to all 4 material science and engineering professional societies. And what we know from studies are that the students find the value in both personal development and initiating the long-term benefits of building their career foundation right away. Now, we have a number of programs that we execute on behalf of this Material Advantage program, but the main culminating event each year is the contests and awards that we execute at MS&T. MS&T is the Material Science and Technology Conference. It's a conference and exhibition that's organized by the 4 partner organizations of Material Advantage. It's held in the fall each year, and exposes students to a large number of networking, learning, and other exchange advantages, and offers students special activities such as the Chapter Leadership Workshop for chapter officers, various contests. We have a contest where they have a chance to time building a dome, and then student networking, travel grants, and other ceremonies. So, thank you.
Great, thank you. Chris, you're up again. We're switching gears to the breakout session on bolstering society-university collaborations.
Yep. Chris Ward again. So Tooling U SME is the Workforce Development Division of SME. When we work with higher education, we look at the breadth of educational offerings in engineering and manufacturing-related programs. We believe it's critical to connect local education communities, employers, and workforce investment boards to develop programs that lead to post-study jobs for students that meet employer workforce needs. So although we are a full workforce development solution for companies, when we're in the education market, our e-learning content is used as part of a flipped classroom so that instructors have more time to spend on applied learning and skills development. When we look at higher education, though, we also look at where is credit being earned. For us, it includes universities, community colleges, and high school bridge programs, because more and more high school students are graduating with certificates and associate's degrees while they're earning their high school diploma. And those students are their logical next step is to go to a community college or a university to continue their education. So we bring industry-driven e-learning that's mapped to industry-driven competencies, our own DOL-approved apprenticeship programs, and other industry certifications into higher education. Students utilize our classes. If they use them as part of our programs, they can take the credit they earned for those classes, and if an employer is actually using our content as well, we can port their transcript to that employer, and the employer can decide to give that student full credit or test them out on that content, which helps the employers expedite onboarding, and it saves them a lot of money. And it makes the value that the community college or the university provides even greater to that employer. So with higher education facing increasing requirements for tracking placement rates and monitoring student kind of post-graduation success, improving employability is absolutely critical. So using industry-driven resources and creating a connected education and employer community is absolutely essential for long-term success.
Leslie here? Oop, there she is.
Good afternoon, everybody. I'm Leslie Nolan from the American Society of Civil Engineers. I'm here to talk about our Exceed teaching workshops. And the goal of Exceed is to improve the teaching skills of our civil engineering faculty. And the way we do this, our volunteer committee members get together and develop and refine the workshop curriculum. What is that curriculum? It's a 6-day hands-on workshop that provides ways for faculty to improve through a series of seminars. They do demonstration classes by their master teachers, and they provide real-time feedback to the participants. And so the participants actually teach a class and get that feedback from the mentors and the assistant mentors right there in the laboratory environment. Another critical component of making sure that the curriculum stays current is listening to input from our department heads through our Department Heads Council. They tell us what their faculty need to improve and what they need from the workshops. We recruit our workshop faculty through previous participants in the program. They become first assistant mentors, where they help a senior mentor mentor the participants, and then they eventually work up to be a full mentor themselves. But there's a mentor and an assistant mentor per every 4 participants in the class, and so it really is almost a one-on-one experience for the participants to improve. So we've had over 800 participants since the program's inception in 1999. And we've gotten great feedback. A number of our graduates have gone on to win accolades in their at their schools and also in nationwide contests and recognition. So it's very successful. Thank you.
Aisha? you're on deck.
Good afternoon. My name is Aisha Lari. I'm with the American Society of Mechanical Engineers, and I'm here to talk about our Graduate Teaching Fellows program. So if you can't see it, you can't be it. That's what our motto is. And just understanding and knowing that myself, if it was not for NSBE, I would have never finished my electrical engineering degree because I was able to see so many students and be able to continue and pursue. But for our Graduate Teaching Fellows program, what we want to do, because most PhD students actually go into industry, we really want to encourage them to look at academia as a career. And so we provide them a stipend for them to be able to teach a full course themselves so they get the experience of what it is to be able to be responsible for a course. And so right now, ME has the largest number of women, but that's just a number. The percent is still very low, like in most disciplines. So right now, it's still only 13%. We want to be able to understand and increase that number, and this way have these PhD students be role models, because this is going to take time. It's not something that happens overnight. So if we are able to have this program, have these PhD students be responsible for teaching this course and groom them, they can then in turn be some of those faculty role models. And so, you know, the collaboration is with the ME departments as well as the graduate students for them to be able to, you know, take on this responsibility of having this course. We've had great success. As you can see, you know, since 1992, we've had 58 fellows. 80% of them are now in academic careers, and 51% of them are women. And so we continue to try to grow this program so that we can definitely influence having more women and minorities become faculty members so that students can see role models who look like them. And so one of our first fellows was Patsy Bracken from Rose-Hulman, and she actually is now on the ABET board, and she chairs the criteria and education committee. So this is a little bit about our program. Thank you very much.
Bill?
I'm Phil Westmoreland again to talk a little bit about another ASCHE activity that is directly tied to requests of the broader society as well as the professional society's interest. The Center for Chemical Process Safety was created as a proactive response after Bhopal, when the chemical process industry was under threat of going under a Nuclear Regulatory Commission type scrutiny. So this was a joint activity. One of the outcomes of that was SASH, Safety in Chemical Engineering Education. Not talking lab safety, not talking personal safety, talking about process safety, manufacturing safety. At the request of the Chemical Safety Board, then we've heightened those activities to meet activities that are requested through ABET, that we have safety materials. SASH is doing it. ASCHE Academy is our online delivery method. The construct is to have a series of modules. So level 1 modules are introduced fairly early in students' curricula, covering topics that are useful as they go into the lab and worry about lab safety, but also as they move to co-ops. At level 2, it's more core activities, for example, within the senior capstone course, where they look at the basics, the background, but then specific hazards that can come up, the assessment and analysis of those, and then also how you manage those hazards and risks. These modules are also being developed, additional modules that will be used by industry with these topics here. So again, this is an activity that is being sponsored by industry. It's at the in response to Chemical Safety Board request and to an obvious need. Thank you.
Great, thank you. Larry? There we go.
Okay, greetings all. I'm Larry Larson from Texas State University, and what I represent to you is that probably one of the most under-recognized but very crucial engineering disciplines is the creation of standards. We use it a lot. Very few students have a clue. Very few professionals know much. So we've had the excellent opportunity to collaborate with the IEEE Standards Organization on informing our students on what goes on. They have their fall meeting in Texas, and they have, for the last couple of years, come to hold a one-day workshop at our facility, teaching the students what it's like, what it's about. And so this is a cool workshop. They bring the technical experts that wrote these standards for wireless and for networking to give technical talks about what this is, what the standards are, how it all works together. And this brings the students. They get to rub shoulders with the big guys. But the real learning part of it is that we have a standards committee meeting, which is a role-playing exercise for the students as the second half of that workshop. And they're all secretly assigned stories. You know the guys, the major corporate guy that knows what the right thing is, the young entrepreneur that his livelihood depends on it. And you also know the old technical expert that talks for hours and hours because he loves his voice. They have to form that standard. That's where the real learning takes place. So we've enjoyed it. It works well. Where this is going, the IEEE is marketing this thing as a boxed set. We in the IEEE are working together with them to develop a version that can be implemented into classes, tagged to IBET criteria, and basically something that can be integrated more into schoolwork. Thank you.
Bill? I think we have the right slide up this time.
Thank you, Ken. Bill Wepfer again. As I mentioned this morning, ASME endeavored on a Vision 2030 roadmap in the spirit of the NAE 2020 with the goal and objective of developing T-shaped students. I kind of like the more provocative concept of pie-shaped students. Two of the recommendations coming out of the study that we wanted to implement, one was a more flexible curriculum, and the other was to infuse much more of the design, build, create, innovate STEM through the curriculum, and we accomplished both. One of the things we did is we needed to change the ABET program criteria. In the old days, the ABET program criteria required ME programs to graduate students who were professionally capable of practicing on both the thermal and the mechanics sides. We made a very simple change, and to or, to unleash creativity and flexibility, and it's worked. So we came back to Georgia Tech, had a series of speakers, people from the likes of MIT and Michigan and all that, 2 years of very intense retail discussions and relationship with the faculty. It worked, it passed. And we've also infused the program with all sorts of design build. The cartoon you see is the original cartoon. We have concentration areas. We're now up to 7 going on 8. But the more interesting thing is that 245 of our juniors and seniors this fall had declared minors at Georgia Tech minors. Industrial design, computer science, business, and all buckets of foreign languages are the most popular. And the strong preliminary evidence says that women students are very proactive. They love the flexibility, and they are participating in these sections in record numbers. Thank you.
And if you haven't gathered it by now, we switched topics to the facilitating industry, academia industry alignment.
Thanks. How do I advance the
large button in the...
Okay, I'm Jim Hill from Iowa State. I'm representing the Career in Education Operating Council for AICHE, the Fellows Council for AICHE, and also the Council for Chemical Research. This issue about academic industrial alignment arose a few years ago when some industrial CTOs were upset, particularly with the apparent shift in faculty expertise away from core areas of chemical engineering, this would be in transport phenomena, unit operations, separations, process control, into newer areas, materials, especially bio and nano. And this was upsetting. It didn't seem to meet the needs. So the profession has broadened into these areas, and this was well documented by a survey of departments and also of some industry. So the question is, does it matter? Well, the survey was kind of limited, and so under Phil Westmoreland's leadership, another workshop was held, sponsored by National Science Foundation, and a much more extensive survey was sent out. 13,000 contacts were made, but there was only about a 4% return rate, which wasn't very good. And the results were not quite as alarming as the first. However, the key messages from industry were to continue focusing on the theory and the fundamentals, but critical thinking is something that had to be maintained as a part of the education. The alignment was maybe not as problematic as was originally thought. Something that was really not evidenced on this slide here has to do with many. Okay, I'm finished. Thank you.
In the breakout sessions. Thank you. Kathy, we're now switching to societies and informal learning.
Thanks. My name is Kathy Leslie, and I'm the Executive Director of Engineers Without Borders USA. An important part of our mission is to provide education and training for the next generation of engineers that allows them to best work with community partners both here and abroad. Our International Community Program is a program outside of the U.S. where we create long-term relationships, typically 5 years, between underserved communities and our student chapters. In this time, these partnerships typically assess, design, construct, and monitor 2 or 3 different types of infrastructure projects. Under the guidance of a professional mentor, our members utilize not only their fledgling skills in project management and design, but they're also learning and using skills in leadership, communication, time management, persuasion, negotiation, fundraising, and others. They must have the skills to meet a new community in a different country, in a different language, determine the right project for that community in that environment, determine what materials are locally available, determine what the community can afford now and what they can afford to maintain in the future, assess and create alternatives, design, fundraise for the cost of travel and the cost of construction, arrange for the delivery of materials, construct, train for operations and maintenance, and then monitor and evaluate. Many of the benefits of participation have been documented through qualitative feedback from our graduated students and from our corporate partners, as well as a broad-ranging study sponsored by NSF. The study notes that EWBers demonstrate higher than average professional skills from their experience in leading teams, managing projects, working in cross-cultural and cross-disciplinary environments. All of this makes our student members, at a rate of about 1,000 students per year, coveted recruits of the world's premier engineering firms, and enhances the image and marketability of universities that host approximately 150 EWB-USA chapters. Thank you.
And Karen?
Hello, I'm Karen Anderson, and I am from SAMPE, the Society for the Advancement of Material and Process Engineering. I am the Vice President responsible for student programs and competitions. SAMPE is a technical society with both professional and student members throughout the world, from academia, government, and industry. SAMPE's members work in all areas of material and process development, from creating the materials themselves to using those materials to create some of the world's greatest engineering feats that you see today. Because our arc of membership is so broad-based, we have a challenge that we need to serve our members' needs and interests. And so today I would like to talk with you about our bridge contest and what we do there. Starting at the top left and moving clockwise, for our student members, we ask the students to design, analyze, fabricate, and test 2-foot-long bridges made out of advanced materials and processes. To do this, they frequently need to use software, the engineering software that they would use in industry, and we ask them to present that data in a similar way that they would have to present it in their future jobs. Additionally, their professors often take the project and use it for a 4-credit class for them, where they can earn credit as a senior project or as an actual curriculum course. For our professional members, next picture over, they donate materials, which are put in kits and sent out to the students to fabricate their bridges, giving them an opportunity to showcase their materials to would-be engineers. Many of the students also go out into industry, into their local communities, and ask different companies to help them build their bridges, which gives the students and those professional members an opportunity to meet and talk about engineering together and work side by side together. Finally, the last picture there, this contest has been going on for 20 years. It's all over the United States at this point, but we've also reached out globally now. The contests are held in Mexico, Brazil, China, and Japan. And the different winners from the different areas now come to each other's contests and compete with each other, which is a wonderful opportunity to broaden their experience, not only in engineering, but also just culturally. Finally, we integrate technologies as we go along, and different technologies emerge. We add categories to the bridge contest. Our last 2 categories that we added were using recycled materials to make their bridges, and also an additive manufacturing contest. There you go.
Thank you. We did have one more presentation. Is anybody from IISE here? Jim Moore had to cancel, so I just wanted to check and see if he had managed to arrange a substitute. Okay, guess not. So we're ready to go on to the breakouts. When you go to the breakouts, remember that the focus of this afternoon is on how. So think about the barriers to your program and how you overcame those barriers. Think of the opportunities that were created and how you managed to take advantage of those opportunities. The breakout rooms are the same rooms we had before, and the assignments are up on the board. We will see you in 45 minutes.